Hello once again, this is Jeff Scott of Rankin Technical College. I've been going over this online PDF that's called MySQL by Examples for Beginners. I've gone through all of Part 2, which gave examples on creating databases and tables, querying databases and tables, inserting, updating, and deleting into tables. And I've also gone through Part 4, where we talked about primary keys, foreign keys, and indexes. What I'd like to do now is to start to go over sections 3, which is on working with more than one table, and section 6, which is more on working with one table. Then I'll come back and do sections 5 and 7. So let's just jump into more than one table. And as mentioned right here, so far everything we've done has involved just the products table. Well, when you think about it, MySQL is an example of something that is referred to as a relational database management system. Well, one of the things about a relational database management system is the fact that you should be able to relate different tables together. Well, that's kind of hard. I don't want to use Acme, I want to use Southwind. Right now, when you look at my tables, so if I describe tables, show tables, you notice I have products 2, and S, and that S is a garbage table, so I can drop table S. Oh, that's a view, not a table. So I can keep that, that's fine. But the point is, these tables are the same table. I just made a copy of products and put it in products 2, so I could manipulate it around without worrying about how to do anything with the original table. So if you look, if I describe products, and then I describe products 2, you'll notice they are the exact same table, except for products, I've added the primary key and the unique, where since I copied it into products 2, I don't have those. So I can actually drop table products 2. I could always recreate it if I needed to. Now if I show tables, I have just products and this view that I did just to show you what views look like. Well, so why am I even going through all that and telling you that? And it's because, as mentioned here, a practical database contains many related tables. Some of those tables will be able to relate directly, and some of those tables we will have to relate through other tables. All right, so as mentioned here, products have suppliers. If each product has one supplier and each supplier supplies only one product, all right, and that's a one-to-one relationship, which we'll talk about in a minute, we can simply add the supplier's data, their name, their address, and their phone number into the products table. But that's not typically how it works. Typically, any one company will have multiple products, and it's quite conceivable that each one of those products could be supplied by a different supplier, or at least that some of those products could be supplied by a different supplier. In addition, the fact that, to think that any one supplier will supply only one product isn't probably the way it's going to be most of the time. So as it says, putting the supplier's data into the products table also results in a duplication of project data. Now I'm gonna go off a little bit here, and this might end up being a very short lecture because I want to show you something. And that is, I want to talk about, for a second here, I want to talk about database normalization. And I'm going to grab what's in here in Wikipedia. It's not the best explanation, but it's not bad. One of the things that you want to do when you're working with databases, especially relational database management systems, is you want to minimize data redundancy. So if at all possible, you don't want the same data to appear over and over and over again in your database. Okay, and what does that mean? We'll show you in just a minute here. All right, so it says, again, Normalization is the process of organizing the columns, which we have been calling fields, and the tables, which they call relations, of a relational database to reduce data redundancy. The key word here is actually reduce. Some people think you want to eliminate it. You typically cannot eliminate data redundancy. And the reason that you cannot typically remove it or totally eliminate it is the only way that you can relate tables together is through common fields. So you'll have some redundancy, but again, you don't want to just reduce it, you want to control data redundancy. That allows you to improve data integrity. What that means is, since you have data in the database as few times as possible, the chance of you making errors or putting something in, doing something you shouldn't do, will be hopefully minimized. So they say here that normalization is also the process of simplifying the design of the database so it achieves an optimum structure. This is a hard one. I could give an assignment and I could have students all sit there and create a database design for some kind of requirements that I give them. And if I've got 20 students, I could have 20 different designs that could be very similar, but each one could be a little different, and each one of them could conceivably work just as well as any of the other ones. Now, this is not a new concept. Normalization actually came about from the early 1970s by Dr. E.F. Codd, also known as Ted Codd. And as it says, it involves arranging the attributes or the fields in relations based on dependencies between those attributes and ensuring that the dependencies are properly enforced by what are referred to as database integrity constraints. Normalization has rules. Actually, they're what are known as normal forms. There are really probably about 9 normal forms. First normal form, second normal form, third normal form, etc. All the way up through 7th normal form. But there's also another one that's called BCNF, which is Boyce-Codd, and there's the Codd normal form, and there's even other ones that you can hear about. What I want to very quickly, hopefully, highlight or talk about here are the first 3 normal forms. First normal form, second normal form, and third normal form. Now, if you're in first normal form and you go to second normal form supposes you're already in first normal form. If you're in second normal form and you go to third normal form, that supposes you're already in second normal form, which means you're naturally already in first normal form. All right? So, we're going to talk about what each one of these means in just a minute. Okay, the first one is first normal form. Okay, as it says, when you're in first normal form, the basic objective was to permit data to be queried and manipulated using a universal data sublanguage grouped in first order language, or logic rather, and that's typically going to be SQL. So, what the heck does that even mean? Well, to be in first normal form, one of the first things is you want to make sure that you don't have any redundant data. So, let's take a quick look here, and let's select star from products. All right. Well, you may or may not agree with this, but we have a lot of redundant data here, especially right there. Okay, and what do I mean? Well, notice I've got pen in a lot of areas. I've got pen or peck in every one of these. All right. What would be better for me to do here with this product code would be, rather than having this code all over the place, and you could argue with what I'm about to say, that because this isn't the best example, but instead of pen and peck in here, we could create a new table that's called this is products. We could create a new table that's called codes, and 1 could be set to peck, and 2 could be set to peck. 1 to pen and 2 to peck. Then this would be 1 1 1 2 1 2 2 2 2 2 2. Now you could argue here and say there's absolutely nothing wrong with this the way that it is. And you know what? You'd be correct. The problem is, what if someone comes in later? What if someone comes in later and says pens instead of pecs? I'm sorry, it says P-E-N-S instead of P-E-N. Right now, there's nothing to stop you from doing that. But if we came in here and we said that these were product, code numbers, a 1 or a 2, and you tried putting in something that wasn't a 1 or a 2, all right, we could, since we would have the 1 and the 2 defined in yet another table, we could keep you from putting in bad data. All right? Now, what we're going to look at in just a bit and what we're going to create as a class here, if I show you my databases, all right, you'll notice I've got an Acme and an Acme 2. Well, later we're going to come in here and we're going to do this. I'm going to describe, let's use Acme. All right, again, you haven't seen any of this stuff yet, but let's show tables. And you'll notice there's quite a few of these. All right, and some of them, again, were practice ones, etc. But originally, this table right here, that table not that table. Originally, the table that's called employees, let me start that again. Originally, that table had in it not only all of these fields, but it also had this field, department name, in it, along with these fields. And it also had, along with those fields, those fields. All right, so my one table had in it ID, social security number, first name, last name, or middle initial, last name, address, city, state, zip, department number, department name, salary, and manager ID. But what ended up happening here is everyone worked in departments 1, 2, 3, 4, 5, or 6. For example, Department 1 was or is IT. And I had IT all over the place, or web design, or shipping, or receiving, and it was repeated many times. By creating a new table, now the only thing I have here is a 1, 2, 3, 4, 5, or 6. In much the same way, and we'll talk about this in a little more depth and breadth of coverage in a minute, if I know somebody's zip code, I can tell their city, their state, etc. from their zip code. So for instance, if somebody said to me the zip code is 63385, I could say, oh, that's Wentzville, Missouri. That kind of an idea. So what we did was we separated that stuff out. But what I'm telling you is, had we left everything in here, so had we had all of these fields plus department name plus city plus state, this database would still have been in what's called first normal form. Because what you're looking for in first normal form more than anything else is, do you have a primary key? And we already do. We have a primary key right here. Now that's putting it very simplistically. But let's see. What is 1NF? And there's all sorts of different things that you can look at in here. But it says first normal form sets very basic rules. Define the data items required because they become columns in the table. We've already done that. Ensure that there is a primary key. We've done that. Ensure there are no repeating groups of data. Well, what are repeating groups? All right. We don't have that kind of situation here, but if we had set it up so that when you put in a person's department number, if we had it set up where you could work in more than one department, and for department number, as an example, and it's not set up like this, but let's say that I worked in Department 1 and Department 6. If it would have been legal here, it's not. But if it would have been legal here to put in there 1, 6, meaning I worked in both departments, that would have been a repeating group. All right. Or if I would have put in, let's say Department 1 is Infotech for information technology, and Department 6 is networking. If I'd have put in Infotech, comma, networking for the department name, that would be a repeating group. We don't want repeating groups. All right? So we've already got this in first normal form. So it says the second group is ensuring there are no repeating groups. Well, again, we've already done that. Here's an example of repeating groups. We have a single customer, and notice the problem here. First of all, what field are we going to use as a primary key? We can't use the ID field because there are repeating groups. So typically when you have a situation like this, what you end up doing is you end up breaking this down into more tables. Much the same way as I showed you what we had originally and how I broke it down from one table into 3 tables. Now they've already got a table here. They've got this customers table, and now they're refining it here. So you've got both a customers table and an orders table. So now look at the difference. All right. Now it is totally legit because you've got separate IDs. You do not have repeating groups. You can say, well, yeah, but you have the same, that's because the same customer has 3 different orders. So what you have there is totally legit. All right? I was looking for a really good definition of second normal form, and maybe I've already got it here. There was a really good article that I had in the past on normal forms, and of course I can't find it right now. So I already showed you first normal form. Eliminate duplicative columns, create separate tables if as necessary. Second normal form. Meet all the requirements of first normal form. Remove subsets of data that apply to multiple rows of a table and place them in separate tables. For instance, as I mentioned to you before, originally I had the department number in this table and the department name. So I was putting in the name. If I have 50 people who work in Department 2, which is shipping, let's say, then I've got shipping in there 50 times. Somebody could spell shipping wrong. All right. It could be, they might, just call it ship or whatever. But by putting in just the department numbers, then I've got shipping in this table only once. So if I select star from employees, there's my employees, and notice there's their department number. But if I select star from departments, now I've got, so for instance, you can see that Paul Knott works for Department 6, and that's networking. What if somebody put that in, they put it in this table, so what if we had the department names in here, and somebody put in networking, and the next person put in network administrator for some reason? There'd be nothing to stop that from happening. So what I'm doing by putting it into second normal form is I'm bringing more consistency to my database, plus I'm making sure that I don't have duplicative data. All right? Then finally, when you want to go into third normal form, you want to remove columns that are not dependent on the primary key. This is where that other one became important. So let me again describe employees, and then let's describe zip, city, state. Originally in this table, I had I had address, city, state, and zip. All right? And when you work with this, you talk about functional dependencies. And what this says is the ID, which since it's my primary key, functionally determines the social security number and the first name, and the middle initial, and the last name, and the address, and the zip, and the department number, and the salary, and the manager ID. All right? And you could make a case and say that isn't really true in a lot of cases. For instance, okay, when we had in here city and state, really zip code functionally determines your city and zip code functionally determines your state. So I pull those fields out, the city and state, from this table and put them in their own table. So that I'd be able to relate these tables together, I took this field out of this table here and put it in as a primary key field here. Right there. Well, actually, I made ID the primary key, and I added zip in here. All right? So now I'm able to relate those tables together. What we're going to build toward is this. Let's say that my boss comes in and says to me, Jeff, I need you to create a report for me. And that report must have a person's first name, last name, department number, zip code, city, and state. In fact, let's make it simpler than that. Let's say we want their first name, middle initial, last name, address, city, state, and zip code. All right? Well, right now, I can select their first name, their last name, their address, their zip code. I can do all that from employees. There they are, not a problem. And I can come in and I can select the city, the state, and the zip code from zip, city, state. So I can do that. It's not a problem. But I want to combine these 4 fields and these 2 fields right here. And right now, I can't do that in what we've learned so far. So I can come in here and I can say select, and the order is up to me. Now I'm going to over document here. I'm going to say e dot first name as first name, e dot last name. You don't have to line these up like I'm doing it. I'm just doing it so you can actually see everything that's going on here. All right. So we have first name, we have last name, we need address, city. Now, the city is in the other table, so I'm going to say c.city, and if you don't get what I mean, just keep watching. Now, I've got a little bit of a dilemma here, and that is I can grab the zip code either from this table or from this table, and it really doesn't matter which one I use. So I'll just use the C. Now, what I have to say is I want to do this from, okay, employees, E, which means the employees table, zip, city, state, C. I guess I should have called it Z. Now, I'm going to put a semicolon in and hit enter. It's not going to work correctly. I'm going to get results, but what it's going to do is it's going to multiply all 12 of these by all 4 of these, and I think at least I'm going to get what's called a Cartesian product join. I'm going to get 48 records back. There they are. And it gave me everybody in all 4 cities for every single record. So it had me living in Wentzville and Lake St. Louis and O'Fallon and St. Peters. Well, that's not right. So let's bring this query up again and we'll add to it. Select that, and that, and that. All All right? Everything there is correct, but I haven't done what's called join those two tables based on a common field. So I'm going to do that right now. And I'm going to say where e.zip equals c.zip. Let me run it. And notice now I get 12. And it's got everyone's correct city, state, and zip code. So what was different here? Well, I'm going to explain that, and I'm already probably running up on time. I am. Okay, so in fact, I will continue this in the next lecture in just a couple minutes.